How are solar systems formed? What if I told you that our entire solar system began as nothing more than a cold, dark cloud floating in space? That every planet, every moon, and even our sun started from the same cosmic dust that's been drifting through the galaxy for billions of years. Right now, scattered throughout our galaxy, there are thousands of these stellar nurseries called nebulae. They're massive clouds of gas and dust, mostly hydrogen and helium, stretching across light years of space. These clouds seem peaceful and unchanging, but they're actually cosmic time bombs waiting for the right trigger. That trigger often comes from a nearby exploding star, a supernova. The shockwave from this stellar explosion ripples through space, compressing parts of the nebula. When this happens, something extraordinary begins. Gravity takes over, and the compressed regions start collapsing in on themselves. As our solar nebula collapsed about 4.6 billion years ago, it began spinning faster and faster, just like a figure skater pulling in their arms during a spin. This spinning motion flattened the cloud into a massive disk, with most of the material concentrated at the center. Picture a cosmic pizza dough being spun in space, but this pizza was millions of times wider than Earth's orbit. At the heart of this spinning disk, temperatures soared as material compressed under its own gravity. When the core reached about 10 million degrees Celsius, nuclear fusion ignited, and our sun was born. This wasn't a gentle awakening. The newborn sun was violent and unstable, shooting out powerful solar winds that swept through the surrounding disk. Meanwhile, in the cooler outer regions of the disk, something fascinating was happening. Tiny particles of dust and ice were sticking together through electrostatic forces, like cosmic lint gathering in a dryer. These clumps grew larger and larger, eventually forming objects called planetesimals, rocky and icy bodies ranging from a few meters to hundreds of kilometers across. The inner solar system, closest to the hot young sun, was too warm for ice to survive. Here, only rocky materials could condense, which is why we have small, dense planets like Mercury, Venus, Earth, and Mars. But beyond what we call the frost line, about where the asteroid belt sits today, temperatures were cold enough for water ice to freeze. This made all the difference for the outer planets. With ice available as building material, planetesimals in these regions could grow much larger. When they reached about 10 times Earth's mass, something incredible happened. They became massive enough to capture hydrogen and helium directly from the nebula, ballooning into the gas giants we know as Jupiter, Saturn, Uranus, and Neptune. Jupiter, the first and largest of these giants, acted like a cosmic vacuum cleaner. Its immense gravity swept up material and even flung some planetesimals out of the solar system entirely. This gravitational bullying actually protected the inner planets from constant bombardment, making Earth's eventual development of life possible. The formation process wasn't smooth or peaceful. Planetesimals constantly crashed into each other in a cosmic game of bumper cars. Some collisions destroyed smaller bodies, while others merged them into larger ones. Earth itself likely formed from thousands of these impacts over millions of years. One of the most dramatic collisions happened when Earth was nearly complete. A Mars-sized object called Theia slammed into our planet with such force that it blasted enormous amounts of material into orbit. This debris eventually coalesced to form our moon, which explains why the moon's composition is so similar to Earth's outer layers. As the solar system matured, the remaining gas in the nebula was blown away by the sun's increasingly powerful solar wind. This left behind the rocky planets, gas giants, and countless smaller objects like asteroids and comets that we see today. The entire process from nebular collapse to a recognizable solar system took roughly 100 million years. That might seem like an eternity, but in cosmic terms, it's remarkably quick. Consider that the universe is nearly 14 billion years old, making our solar system's formation just a brief chapter in cosmic history. Today, we can observe this same process happening throughout our galaxy. The Hubble Space Telescope has captured images of protoplanetary disks around young stars, showing us solar systems in various stages of formation. Each one is unique, which explains why the thousands of exoplanets we've discovered come in such incredible variety. Our solar system's story reminds us that we're all made of star stuff, forged in the nuclear furnaces of ancient suns and assembled through billions of years of cosmic evolution.